everyone. The name of our project is AudiBraille. So basically what our project does is help the visually impaired people to read Braille script. Our project converts the Braille script into audio.
This is our final product after connecting the launchpad and booster packs. The first we have is TM46129 launchpad, which is then connected to the educational booster pack MK2, which consists of joysticks and some buttons that we use to detect the Braille script. The TM46129 launchpad is connected to the breadboard booster pack, which is connected to a breadboard which consists of a buzzer, and the connection established by the wire.
So on the right we have a standard Braille cell, and on the left is the letter M in Braille. As you can see, the black dots represent a raised dot and the white dots represent a blank dot. So how our device would work is we would pull our joystick up to represent 1 in our code, which means a raised dot, and joystick down to represent 0, which means a blank dot. So in this case for M, we'll be pulling the joystick up and then down, up, and then down twice.
So here we can see the demonstration of letter B in Braille. We'll do our demo on this one. As we can see, we'll need 2 simultaneous upward push, and the 4 remaining are downward push.
To start the recording, we should press the button S1.
So as we can see that we have 2 simultaneous dot inputs and 4 continuous no dot inputs. In our case, dot inputs correspond to 1 and then no dot inputs correspond to 0. So when we concatenate all those values, then we get the integer 110,000, and we have an array where we store those integers and their corresponding Braille characters, and in our case this 110,000 corresponds to a letter B in English alphabet.
So in this case, for our character B, we have a special sound which is being played as. So here is our algorithm on how we produce our sound for the corresponding character. As we can see, we have a 5x5 matrix. Each character has a corresponding position in the matrix, and depending on the position, we decide on how to produce the sound. Since the character Z is not in the table, it is represented by playing the sound only once.
So there are 2 different kinds of sound played. The first sound corresponds to the row number and the second sound corresponds to the column number. Let's hear the sound played for the character B again.
We heard 2 different types of sound. The first sound was played once and the second sound was played twice.
The first type of sound being played once corresponds to the row number of B, which is 1, and the second type of sound being played twice corresponds to the column number of B, which is 2. After the completion of project, we like to thank Dr. Gedare Bloom for advising us throughout the semester and guiding us to complete this project.
It was really a great experience in knowing the interaction between the hardware and software together.